Hi Year 10s, just when you thought trigonometry was over, it is back. 2 new rules for you to learn for next week, the sine rule and the cosine rule. Here they are. No prizes for guessing which one's which. This one is obviously the sine rule because you can see it involves sine, and this one is the cosine rule because that's what obviously this cos stands for. Just like with right angle trigonometry, we do need to be able to recognize how sides are labeled, okay? For these rules, it's not so important looking at what these sides are called, but just how we label them in relation to the angles that are opposite. If this angle is represented by a capital A, then the side opposite is represented with a lowercase a. Here we have an angle represented by a capital C, so the side opposite is represented with a lowercase c, and this angle here would be a capital B. The triangle down here, we're going to have a capital S, capital T, and a capital U to represent the angles, lowercase d, capital E, capital F over here. Now, as you can see, the letters on these triangles do not correspond with the letters in the formulae, but don't let that upset you. All you need to remember is to use the sine rule, we must always have a side with an angle opposite. If we don't have the values for these two, then we can't use it. It doesn't have to be A and A, it could be S and S, it could be E and E, but we must have a side and the angle opposite to use the sine rule. For the cosine rule, we need to have 2 sides and the angle in between those sides. This triangle is labelled D, E and F, so for here, this would be side F, side D, and the angle in between those sides would be angle E, okay? So we must have 2 sides and the angle in between to use the cosine rule. Right, so let's have a go at using one of these formulas. Here's our triangle. Are we going to use the sine or cosine rule? Well, we have a side, we have the angle opposite the side, so yes, you've guessed correctly, we're going to use the sine rule. So I'm going to get rid of the cosine rule so it doesn't confuse us, and I'm going to concentrate on this triangle and the sine rule. You'll see that the sine rule comes in 3 parts, but we only ever use 2 parts at a time. We're going to label the triangle. You can see that the angles are all labelled with capitals, and I'm going to label the sides with lowercase letters, H, F, and G, and then I'm going to substitute into my formula. So the ones that I know then, I know that I have 6.4 divided by sine 42 is going to be equal to H divided by sine 84. By simple rearrangement of the formula, we should now be able to put into our calculators 6.4 divided by sine 42 times sine 84 and get an answer of 9.51. Okay, second example. Here's my triangle. Am I using the sine or cosine rule now? You should see we've got a side, we've got another side, and we have the angle in between those sides. So it'll be the cosine rule. We'll get rid of the sine rule and we'll focus just on using this formula. Once again, substitute in, and we're going to have x squared equals 8 squared plus 5 squared minus 2 times 8 times 5 times cos 43. The answer for x squared is 30.49170, and we should remember from Pythagoras that this is x squared, not x. So we need to square root our answer. So So the answer for x is 5.52. So far we've been looking at trying to find the missing side. Now we're going to try and find a missing angle. Am I going to use the sine rule or the cosine rule? If we look at this triangle, we do not have a corresponding angle inside that we know the values of. Therefore, we need to use the cosine rule. The cosine rule, as it's currently arranged, is to find a missing side. So we need to rearrange this formula to make cos A the subject, and that will help us find a missing angle. So we're going to bring 2bc cos A onto the other side of the equal sign, making it positive, and a squared over here, making it negative. We still don't have cos A by itself, so I need to divide by 2bc. And now I've made the angle the subject. Now for a simple substitution, we should be able to calculate the size of this missing angle. So cos, and for this example, it's cos D equals 10 squared plus 14 squared minus 8 squared, all divided by 2 times 10 times 14, which gives us a cos D of 0.828574. Remember, this is cos D, not the angle D, so we need to do the inverse of cos, so that's shift cos, and it gives us an angle of 34.05. Okay, this is the last worked example I'm going to do with you. Let's have a look at this triangle. We have a known angle. We also have a known side opposite that angle. So we're going to be using the sine rule. So let's get rid of the cosine rule and focus on this. Remember, we only use 2 bits at a time because that's all we need. But before we use it, just like the cosine rule from before, we need to rearrange it. At the moment, it's organized to find a missing side. And to rearrange this, it's much easier than the cosine rule. We just flip. So, it is now in the correct format for me to find a missing angle. I'm going to substitute my values in, which will give me sine 64 divided by 12 is equal to sine Q, which is the one I want to find, divided by 13. And once again, rearrange that so that we have sine 64 divided by 12 times 13 will give us sine Q, which will give us a sine Q of 0.9736, and it keeps going, 96935, going on and on. Remember, we have to inverse this so that we get an angle Q of 76.8 to 1 decimal place. Okay, year 10, here's the bit where we find out if you've been paying attention. I want you to pause the video now and have a go at these 2 questions trying to find x. So press pause now. Okay, I'm assuming you've come back from pause. The size of x for question 1 is 30.05, and x for question 2 is 81.5. Now obviously that's not enough. I want to see the full working out in your books on Monday for how we get those 2 answers. Here we have a flow chart. In this flow chart, it lets us know which branch of trigonometry we need to use. And I want you to copy this into your books and complete it for the next lesson. I'll give you a little clue as to one of the answers. So, is the triangle right angled? Yes, we're going to go down this branch. Does the question involve any angles? No. If it doesn't, then what do we use? Hopefully you saw that. So I want you to complete the others letting me know which formulae we should use. See you on Monday.